Okay, so next up is our panel of new space technology startups. And I would like to invite Palak Patel, the moderator, and the panelists here. And Palak, I will let you do the introductions. All right.
Hello, everyone. I hope you can hear me. All right. Good morning, everyone, and welcome to the New Space Technology Startups panel. My name is Palak Patel, and I'm a PhD candidate at MIT working on novel space materials for the extreme space environment. I'm also a NASA graduate fellow with the NST GRO Fellowship, and I will be the panel moderator today. All right, so let's begin with introductions. I'd like to introduce our panelists. We've got Eve Ruff, who is a guidance, navigation, and control engineer at True Anomaly, where she designs, tests, and operates highly maneuverable satellites with a full payload suite for space domain awareness. True Anomaly is taking part in the Victus Haze mission, which will be the first demonstration of a realistic threat response scenario by the US Space Force. Prior to True Anomaly, Eve worked on creating novel trajectory optimization algorithms between the Aerospace Controls Laboratory and Draper while getting her master's at MIT. We also have Jacob Rodriguez, who is the founder and CEO of Oligo Space, which is building a manufacturing and software infrastructure to automate the design and production of payload-centered spacecraft. Before Oligo, Jacob was a 4-times JPL intern and a lead of the WORMS project in the Space Resources Workshop as an AeroAstro undergrad until he was awarded the Thiel Fellowship last year, pushing him to leave MIT with 5 classes left in his undergraduate program to work on the company full-time. Their growing team in Hawthorne, California is now preparing to launch their first 100-kilogram spacecraft on Transporter 15 this October. We then have Maximillian Bhatti. Maximillian is the co-founder and CEO of Basalt, a space startup building AI space autonomy products for spacecraft and swarms of spacecraft. A constellation of 3 in-house satellites utilizing Basalt software is manifested to launch in late 2025. Before dropping out to attend Y Combinator at the age of 20, Max worked at MIT AeroAstro on spaceflight projects alongside his now co-founder, Alex. Max has worked at SpaceX and the Aerospace Corporation. And finally, we have Scarlet. Scarlet is the co-founder and CEO of Mithril, a space technology company building dynamic reflectors for a new era of flexible satellite communications and remote sensing. She completed a BSc at MIT in aerospace engineering before entering the space industry. After 5 years with SpaceX and NASA Jet Propulsion Lab as an integration and test engineer, she returned to MIT for an MS in aerospace and an MBA at MIT Sloan. She and Professor Zach Cordero formed Mithril Technologies to realize the potential of the actuation technology being developed in his lab. Thank you so much for being here, and thank you, audience, for being here as well. All right, so without further ado, let's begin our panel discussion with a couple of questions. All right, so beginning with question number 1. What was the moment or realization that led you to start or join a space technology startup, and how did that vision evolve into what you're building today? Feel free to begin.
I can start with that one if nobody else wants to chip in. It was simultaneously serendipitous, but I think I forgot the name of the speaker earlier. He said if you're prepared, then when you get the opportunity, it feels lucky. I ended up crossing paths with Zach a number of times, even though I wasn't a student in his lab during my dual degree LGO program. And we both were just very excited about the potential of the electrostatic actuation technology for membrane reflectors of all kinds and about what it could do, because honestly, one of our problems as a business is that we have too many applications. And I realized, it's really easy to look back and think about technological progress as inevitable, but these things don't make it out of the lab, they don't make it into the real world unless somebody does that. And I realized there pretty much was nobody else who was going to do that. So that was a good moment for me to take a risk with my career and go in on the deep end.
Oh, I think Jacob's got to do it next. Your story.
Why do I have to do it?
Because he said so, go.
Okay. So I guess I kind of have a similar story to Kerr's, which is I didn't actually think I was going to do a startup until it kind of just happened. I think back in the Worms program, I was working with like George, and we were going out to all these different conferences, and then we get to present to people like Jeff Bezos, and you kind of get thrown into this, like, all the other people presenting were either research labs or startup companies. And I was on the path of basically going forward, doing my master's degree. I wanted to do my PhD. I wanted to work at JPL. I mean, I was there long enough. Everyone's like, you might as well stay. And it kind of became this weird idea where people kind of threw me into the ring. And I think there's some people that said, you know what, you might try doing something that isn't research. You might try doing something maybe a little more industry. And I think there was these small little pinnacles of the research that I was doing with the whole Worms project, with the Space Resources Workshop, that I wanted to do kind of for the rest of my life. And I didn't know what exactly that was going to be if I chose a different job, if I worked at JPL, if I went around with my PhD. And I think the idea of being able to turn this company into something that really manifests every single thing I loved about building that team in that basement, by that concrete blast chamber, if anyone knows what I'm talking about, was absolutely a thing that just made it go from 0 to 1 for me.
Nice.
Yeah, I guess I can go.
Now it's your turn.
Yeah, I guess I kind of did a lot of labs, I did a lot of research, some internships, and then, after a while, you kind of think to yourself, like, oh, shit, like, there's got to be something more exciting than this. And so I think I was kind of grasping for something that could have been more exciting. And then kind of the opportunity came up, just on a whim. Alex and I were like, oh yeah, we should apply to Y Combinator. Alex is over there. And then, to our disbelief, we got in. And then, our lives have been very, very different since. I think the intellectual stimulation of a startup just cannot be compared to any other type of work. And I think that it kind of forces you to kind of unlock another gear. And technically, people-wise, it's awesome. Yeah.
I definitely agree with the sentiment of, like, I've never worked harder or had to think harder every single day of my life than working at a startup. I was drawn to True Anomaly when I really, at the moment I heard about the company, and the mission of trying to create a more safe, secure, and sustainable space, and become like a leading industry partner for the United States Space Force in particular. I thought that was just an incredible mission because we're so reliant on space every single day in so many different ways, civilian and government purposes. And while those assets in space are so critical to how we live our life, they're also a great vulnerability. So I think True Anomaly is working towards trying to fill in like the missing link in this really critical chain of defense for our country. So I'm just inspired every day going and trying to work on this mission I believe in, while also getting to work with like some of the smartest people in the industry, and always pushing ourselves to find the next thing and improve the industry and our design in pursuit of like greatness and space superiority.
Oh, as a person, by the way, who has not done research in the traditional sense, I am going to counter a little bit on you guys. I think there's some incredible work that goes on in research labs, and we need a different kind of person from us to be doing it. We need a kind of person who's willing to do something that it's not clear what it's used for, and we're the sort of folks who take it maybe from 1 to 2. And I would say the folks in research in the early stage are really the 0 to 1. But that's just me.
Oh yeah, no, definitely. I think before the technology gets commercialized, it has to exist, right?
Oh yeah.
This is where they get invented, right?
Yeah, and I think sometimes we discount that as startup people, but that's because we're different people from the academics, and we need them too.
Mm-hmm. Yeah, definitely.
Well, yeah, it's very interesting that you were all in the same setting as a lot of researchers and able to realize that you are like startup potential. And it was really interesting hearing about how diverse your backgrounds are, as well as the beginning of like working towards a startup. Yeah, all right. Second question. So space startups face tough technical, financial, and regulatory challenges. What has been the biggest obstacle in your work so far, and how did you approach overcoming it?
FCC licensing.
Yeah.
And I approached it with lawyers. And now we're good.
All right.
Yeah, I remember, like, I think this January, February, I think I was working like 18 hours a day just doing paperwork. Space missions are made of paperwork.
Yeah.
Yeah, that's a fair point. I'd actually say for us, it was definitely funding. And that's because we were trying to do something a little bit different. And this is again a little bit on the countering the narrative. Not everything is going to be VC scalable. Not everything is something you can pitch as like a $10 billion potential return. And that doesn't mean that it doesn't have value. And that's also something that bothers me intensely about a lot of research that happens that doesn't get commercialized, that doesn't get into the real world because a VC won't look at it, but it has value. And we know that because we have customers, but we have a lot of VCs who aren't interested in it because it's like, all right, so you're telling me this is maybe a $1 billion market and not a $10 billion market. We'll see you next week. So that was actually a bit of a struggle initially. We actually have been able to figure out a lot of modes of pulling ourselves up by the proverbial bootstraps, and that was a really tough time for the first year initially. It was really just me and my co-founder, who's a professor, so he's not full-time. But getting through that phase was just a really critical learning experience in how do you get, how do you make gains without what you would think of as resources.
I think it's funny that all of our answers are not like, write the software, test the hardware, write the next algorithm, do the math, because we're all engineers. They're all like kind of mundane things. Like my answer being at, I guess like a further along startup, deep tech company we like to call ourselves, is something also very mundane, like when we're building, designing satellites, trying to deal with supply chain issues, which is not very exciting to talk about, but we're trying to iterate from mission to mission in months, not years, and timelines for very critical components that are necessary to operate a spacecraft have lead times of over a year. How are you supposed to fly, fix, fly rapidly and able to produce satellites and design new technology at the pace of the need? That's really something that at True Anomaly we struggle with every day, and I think the way we try to counter it is maintaining a balance in between having a stable baseline for your technology and really understanding what components and capabilities you already have while trying to iterate and improve where you can in the timeline you have.
Yeah, I think I can bounce off of that. I think people would be surprised by the number of space companies that kind of hit like really fatal amounts of trouble because their suppliers are screwing them over, or not cooperating on time, or they're slipping by 6 months, you know. I've talked to CEOs where their company's been, nearly destroyed because a supplier lied to them about, the state of their components that were on the way, and it's rough out there.
Absolutely true. Yeah, we're bringing in some new people at the moment, and I'm specifically recruiting real hard on a person with a supply chain background, with a global understanding of how that works, because it is a real concern. You're so right.
I feel like sometimes you gotta somehow fly there and then sit in front of the CEO and yell at them, and then they'll be on time,
We do that with
our
suppliers.
Yeah.
We show up and we say, how can we fix this problem? What do you need from us so that you can get us what we've paid and asked for? It's definitely can be frustrating, but it's all part of the developing industry. We're all here trying to push the frontier. A lot of the markets aren't there yet. A lot of the supply isn't there yet, but hopefully we'll all continue moving in the right direction.
Mm-hmm. Absolutely, yeah. From basically hearing everything that you all said, it's so different when you think about the sort of research and development we do in research labs where, we're doing, a lot of our challenges are technical and we're reading papers, figuring out the state of the art, and then iterating on that in our lab. And I feel like this is a whole other ballgame. Yeah. Wow, yeah, thank you.
I would love to do more technical stuff that is easier.
And more fun.
And more
Yeah.
fun.
Yeah, spoken like a true MIT person. Right. How do you balance the need for fast iteration, which is a core trait of startups, with the long timelines, complexity, and high stakes of developing space technology? So I feel like you talked a little bit about that, but could you talk a bit more?
I think for us, given that we have like this insane accelerated launch timeline, it really comes down to we wanted to figure out whether this idea can actually generate revenue as fast as possible and what the needs of these stakeholders actually are. You can go around, we've interviewed like, I think she's like over 2,000 different people to understand like what they want in these specific spacecraft. But it only shows once you actually put the reservation agreement, put that deposit requirement in, and understand who's actually putting the money down. I think for us, it's like balancing this idea of wanting to vertically integrate everything to minimize supply chain dependencies, but also trusting the existing global supply chain that does exist with reasonable lines and having 4 backups. We used our 4th backup, and now we finally have hardware, right? And I think one of the biggest questions I like ask people and why I want to have like the most specific answer is like, how as a company do you get your first dollar? And I think that speed towards getting like real life revenue is the thing that should drive kind of your first mission, what's your first product and what's your first offering, while also making sure that that is not straying off of your critical path on how you actually define your real kind of value proposition as a company.
I would definitely second that, because understanding what your first dollar is compared to what your overall mission is, those are often 2 different things, and making sure that they converge is non-trivial. We found that as we've added more people to the team, it's actually gotten easier because you have more people who are able to counter you and act as a devil's advocate. I'd also added, because I spent 5 years as a test engineer, testing constantly. And we're figuring out how to build just a simulation for virtual testing that we can run faster, but figuring out how we do hardware testing on a faster loop is just so critical. And I think that gets devalued in an environment where people value design. I've seen this be a problem in a number of different environments of all different stripes. You know, this is not confined to any one sector, but actually trying it out is so key to knowing what you can and cannot do.
Yeah, I feel like we're all saying similar things. Like the way I view the balance between trying to iterate really quickly and how complex designing novel spacecraft can be is just your risk tolerance and your risk posture and how you view that and where you want to burn down your risk versus where you can accept risk. So when I look at True Anomaly, we launched our first 2 satellites, I think about 1.5 years after like design started, which was a very aggressive timeline. We took a really aggressive risk posture on our performance in order to meet like an elevated or like rapid launch schedule. And that comes with, a whole series of decisions and processes that you have to work through. And I think like our first mission, we didn't achieve as much as we wanted because we took a higher risk profile on some aspects and compromised on others. And I think what's important, though, is moving quickly is what we're saying, right? Like you have to move quickly. You have to learn. I think it's better to do than to not to do, and if that means more risk. And I think we're very lucky that we're in a point in the industry where we're able to take the risks, right? Like 10 years ago, you had a space company and your first mission was a failure, you'd probably be out of business tomorrow, right? But now we're able to take the lessons learned, fly, fix, fly, and hopefully be able to use that risk in order to build flight heritage and get a first mover advantage in whatever industry you're in.
Yeah, I think, I think I definitely agree with what you guys are saying. I think maybe it can be summed up kind of, especially what Jacob was saying about, what's kind of important for your first dollar and, what you were saying about what's important for your first mission, and kind of be summed up as like your best friend's the delete key. So like I've worked on missions, right, from like NASA-funded science missions to like Starship, right? And so the risk posture can be, it can vary, right? It depends on the circumstance you're in. But I think one thing that stays in common that is really easy to look for as an engineer is like, hey, like this thing that's going to take me another 3 months, do I really need to do it? or can I just skip it, right? Because I'd say like maybe a good 60% of the time you can skip it, right?
Developing your muscle of when is something worth really doing right and when is something worth doing okay.
Exactly.
Actually, I had this interaction when I was at SpaceX. I worked in Crew Dragon, and I had to do a lot of interfacing with the NASA commercial crew folks, who were frankly terrified that we were going to kill their people.
I also had that experience. Yeah.
And they had good reason to be, I'll be honest with you. A lot of people on my team were very cavalier about things that they should not have been. And I had to go to my team and be like, hey, those guys wrote the book on human space flight. Maybe we should listen to them. And then go back to NASA and be like, we swear we're not trying to kill your people, but like, we don't understand why you wrote this requirement. And then they'd give us this very long backstory, which usually involved some horrifying situations. And the folks on the SpaceX end would kind of come around. And that was where, you know, they were used to using the delete key a certain percentage of the time, and we had to recalibrate.
Yeah, I think that's definitely something that goes along with like, okay, how bad is it if it fails? Because like I think with Crew Dragon, it's kind of like maximally on one end of the scale, you know, and then Starship, you know, blows up every other launch.
Did they show you pictures of their kids all the time? Because they did that to me.
They didn't do that to me. They were very mad. They were very mad at me once. Yeah.
Oh no, I got too many astronaut kid pictures. But yeah, that the original NASA stoplight chart, you're green, you're yellow, you're red. If you guys don't know what we're discussing, highly recommend you Google that. Calibrating your sense for that.
And then they admit that the requirement, they don't know why it exists, and it comes from Apollo.
Oh no, actually, in that case.
Some of them on Crew Dragon, we like those requirements. Those ones are good.
All the ones that I asked when they wouldn't explain to me, I had to build that relationship, and then they'd pull me aside and they'd be like, "Look, someone almost died on shuttle because of this thing that we never told anyone about."
Definitely.
It scared me to death.
Crew Dragon is very well put together.
It is now.
Thanks to you.
20% of my sanity in that.
Do you have any wild stories like that with respect to like maybe your startup, or are those generally things you'll take me aside 10 years later and be like, look?
Oh my God, there was this one time I was doing like international work. A lot of the stuff our company does is like we're going to every single country and speak with their like leaders of space agencies and work with their local governments. I almost got thrown into like the craziest UK like mafia because I stayed in a hostel to save a quick buck before we raised like our first round. And it was like, you go over to meet this leader of the foreign investment agency. He says, I'm not gonna do business with you unless you outdrink me. I was like, I'm Mexican, so let's go. And it was like that whole thing happened, but it's just like, I think in our specific scope of Oligo, we are such an international company where we be doing these types of interactions in Japan and South Korea and Kenya out of all places, like saying, oh, let's go do a business walk. We're gonna go check out like the rhino outside. And I'm just like, okay, right? Mm-hmm. So I think those types of crazy stories that are so fundamentally rooted with people is probably the coolest thing about doing a startup, because at the very end of the day, you're really just doing everything you can as a company to bring value back to the people that actually live on this planet.
Yeah, I think something important to keep in mind is that like no matter how much shiny technology we put on these things, like, you know, all of the business stuff is, you know, it's really, when people talk about business, what they really mean is, you know, relationships with people, right? Like you were talking about with NASA. So I think one of the most important things that I've spent time doing is really talking to people, executives of space companies who are having trouble with, you know, thing A or thing B. Right, guarding those relationships with your suppliers is really important. Right, making sure that they understand and, you know, respect what you're trying to do. I think that going from like because before making a start, I was like kind of purely a technical person. I did science, I did engineering, and I think, you know, now kind of coming into the entrepreneurship side of things, it's more like, okay, it's great that your tech is good, but the question is like, you know, how are you going to work with people, right? Especially, you know, like Jacob was saying, all over the world. Like, you know, I've had to, I can't tell you the number of dawn flights I've had to take to the other side of the world to, you know, discuss things with, you know, the supply chain or the, you know, potential customers, and, you know, I think that when you work in space, it's very apparent how similar all of us are.
Yeah.
You know?
Rosetta Stone is better than Duolingo for languages. Top tier tip, always learn the language of the person that you're talking to in that specific country.
Oh, no, that's a real thing.
100%.
I have gotten in, I've made some really good relationships by looking at someone's name tag, looking up, and then telling him, hey man, that is a Hungarian-ass name. And I said it in Hungarian and it worked.
Boom.
Oh, all right. So yeah, building relationships is definitely how you go about doing good business, in at least the space sector for sure. Yeah. All right. So what's one piece of technology, whether a part of your own startup or from another company, that you believe will be transformative to the future of the space industry?
Well, I know during those lightning talks, I was like, those are very well timed because my answer was going to be new and improved methods of propulsion. I think too often the lifespan of satellites, right, are limited by their fuel, and there's so many downsides to chemical propulsion. And there's all sorts of assets in space that we can't really use their full ability because we're so constrained by fuel usage and not able to move confidently and quickly and do the maneuvers and burns that we want to perform. So I think like True Anomaly, we're working to have all of our spacecraft have a full propulsion system in order to be able to actually go perform like RPO and maneuver between orbits and do SDA activities. And I think furthermore, if we ever want to go beyond LEO and GEO and the moon, we'll need advanced propulsion systems to become an interplanetary species.
If I could build on that, because I think you're absolutely right about the prop technology, and it was very cool to listen to the lightning talks. Beyond that, reconfigurability and an in-space maintenance of spacecraft, extending their lifetime so that we can have a real space infrastructure. And that is part of the overall vision of Mithril because we make these reconfigurable dishes. If we have more software-defined hardware, if you can lease a spacecraft and reprogram it for a particular application, if you can refuel it and ensure that your propulsion is going to last longer in space through whatever means, that changes the game immensely. It changes the need, it changes the cost dynamic by 10x because don't get me wrong, I love Starship. I love the idea of lowering launch costs, but it's not the only thing. So,
oh yeah, no, definitely. Yeah, I think you definitely have a point there. I think like I think it's gonna be really interesting to see what happens. Like you're saying, like having reconfigurable space hardware and new space software to help you reconfigure it. I think the interesting interaction comes when you have something like what Jacob's building, where it's like, okay, we've got new ways of making the spacecraft, and then we have like what you're building, which is like, okay, now the spacecraft can also be repurposed in orbit for all these different things. I think it's going to be a question of how do we turn spacecraft into more useful assets, right? And I think a piece of that is hardware, and a piece of that is software. And I think that as we develop higher power rad-hard chips and flexible technologies, right, better flexures, additive manufacturing, I think all of those are going to kind of have a confluence, in the next 10 years. And I think it's going to be really interesting to see, what people are going to do in orbit, as that bar of effort goes down.
I agree. We were, just before we got up here, Maximillian and I were touching a little bit on multi-orbit architectures. And I think what we're all discussing is kind of the commodification of space platforms. If we can do that, we can do more of a end-to-end integrated infrastructure, all the way from the highest orbits to beyond Earth orbit to the ground.
I think for me, I'm just like super excited about digital simulations. A lot of the work we're doing is like digital twinning, doing parallelized compute. You need to be able to go really, really fast without sacrificing any type of like risk tolerance, not hitting specific tests, not hitting specific checkouts. And I think that's been an amazing way to kind of go as fast as possible while checking all the boxes, but yet not creating black boxes that no one can see. It's like imagine getting all the EGSE or the electrical ground support equipment on Psyche, Europa Clipper, and Mars 2020 expedited and be going 10 to 20x faster. That is really going to enable us to build whatever spacecraft we want and get all the checkoffs we really need. And I think we're finally getting some compute level hardware and some software that can properly run these things. So that's what I'm super excited about. And it leads to really awesome autonomy with the stuff he's doing too.
I'm with you on that because I think the rapid testing is incredibly important. Well, you were at JPL. Did you see the Mars 2020 test beds?
Oh my God.
Oh yeah, I slept there for like 2.5 years. But yeah, same thing. If we have software testing venues, they don't have to be perfect, but they have to be good enough so that we can buy down the risk for our hardware testing. I think you're absolutely right. That just speeds up the iteration for everything we've just discussed.
Mm-hmm. Yeah.
All right, yeah. I think I'm definitely interested in all sorts of space technology, but I liked the ones that you all picked out because I'm a very materials-focused person. So I look at a lot of solutions or to problems from a very hardware perspective, and I appreciate that you talked a bit more about autonomy and software.
I think making metal from lunar regolith is the coolest thing.
Yeah.
Thank you. It was the hard work of a big team at MIT. We tried our best.
Oh yeah, George even tried to rope me into that for like a semester, and then I.
Oh yeah, no, you were leading that effort. Absolutely.
Yeah, and then I threw it to you because I had too much to do. But no, Jacob, no word of a lie. I used to be a GRA in East Campus. There was a piece of graffiti that I'm pretty sure is at least 20 years old, and it said, "Don't just stand there, electrolyze the moon."
Yep, absolutely. Yeah, you sent that to me, and I'm like, oh, this is it. I hope it's still there.
EC's under construction. I don't think it's still there, I'm afraid.
Unfortunate.
I think
Absolutely
materials
not.
is kind of the step zero. They're definitely the kind of catalyst for all of the stuff to happen.
Everything, all the stuff that we've just talked about relies on the hardware. And don't get me wrong, I love software-defined satellites. That requires that you have the hardware to do it. That requires that we have rad hard chips, as you said. That requires that we have systems that we can simulate. And so the materials kind of underpins everything.
Yeah.
Absolutely. Now we just have to say that to NASA 100 times. All right. Okay, what qualities do you look for when building your team? And how do you cultivate a company culture that thrives in the unique environment of a space startup?
I think I can go for this one. So it's really hard, first of all. So it depends, first of all, I'll caveat this by saying it depends what stage of the startup you're at, right? Like True Anomaly is much further along, right, than I am. But when you're at kind of the 1 to 10 person stage, I think finding people to come along with you on that journey can be really, really hard. So like they need to be willing to just learn whatever the heck they need to learn just immediately. Like one of our engineers, Thomas, so we bought a clean room facility to go in our office, and not all of the beams arrived. And so in the course of just 1 weekend, right, Thomas learned how to weld and work with steel, and the next day he was stacking dimes and powder coating the beams for the clean room.
All right.
And the next week we had a clean room, right? And thank goodness we're still on launch schedule. So, that kind of adaptability is really hard to find in people. And I think it's less of a technical skill or ability, and it's more of like a personality and an attitude towards life that like, okay, I'm down to solve like unknown problems in unknown ways and learn as I go. And I think if you have enough energy and you attack that, I think it's going to go well. I think I've got a saying that, success is, talent times energy squared. So if you have the energy, right, that you put into it, then it's going to go well. So I think that's the most important thing to look for people.
All right.
I don't know if it's energy that specifically, because energy could be an explosion. It goes in all directions. To borrow a word from probably Eve's company, I like the concept of directed energy. And so for us, usually we've been recruiting for really specific skill sets. Oh my God, RF engineers are black magicians. But we've been looking for people not only with the energy, but who are really interested in applying it in a certain direction. And honestly, that makes an organizational job much, much easier because you can have a lot of brilliant people whose efforts all go like this, and your resultant is zero. And aligning those so that they're cohesive is not a trivial job, and bringing in the folks who are not only energetic, but they really want it to succeed, it just massively improves the whole team's chances of having that cohesion.
I think now that we're at the stage where we've brought on people like twice my age at the company. I think it's really funny because the hiring idea was still always the same. I think when I go back to even before MIT, there were these select people that took a chance on me, because before I had MIT on a resume, before I had JPL on a resume, before I had any of this stuff, I was still that like person. And I think if you were to go back in time to understand what that was, it really comes down to like directed energy into like massive opportunity exploitation. Like if you're put into a setting, how do you actually take absolute advantage of being within that environment, being within that room? And how do you properly just like have high utilization of whatever kind of environment you're getting placed in? But yeah, I think that's something where I think one of our first hires was someone from University of Arizona, master's degree in aerospace engineering. And a VC asked me a question saying like, why is this your first person? I'm like, first of all, this guy has like 7 first author NASA publications and a patent with like the STMD. So like, therefore, there's so much stuff you don't see. But the one thing I like am extremely wary of, there's always this pressure to appeal to the projective audience in the startup world. But I think our hyper focus is we hire for what we actually need. And it really helps with like hierarchies, because you're not just hiring someone to be head of something for the sake of being head of something. It's like, this job literally needs to get done, and it requires X amount of years because you've seen this over this amount of time. And it makes it super nice where you have the 40-something-year-old working right next to the 23-year-old, and you're all basically doing this and getting the spacecraft ready for October. It's one of the coolest feelings in the world.
Yeah, it definitely resonates as far as like the VC thing. Like what we look for is low ego. When we talk about when we do interviews, we want to hear you talk about the collaboration you did, how you worked with teams, and how you came together to like build something bigger than yourselves. Because at a space company, right, like everything is so interdisciplinary. You need to work with so many teams. You need to understand you're probably not the smartest person in the room. I know I've never felt like that here or at True Anomaly. And I think that's a good thing is understanding that and be able to put that aside. At True Anomaly, I think in the beginning, we always went by the motto of like, what would it take? Which I think is in the early stages, like you guys are saying, the most critical thing is like what energy, what purpose, what motivation, what mission will it take to get where we need to go? And now as we've kind of become a little bit later stage, I think it's also important to keep in mind, just say no, understand what the work is that is the most impactful and most intentional to get your mission or technology where it needs to be, and say no to the rest.
I think a really big thing though, it's like one of the core questions I've asked every single person is like, they could be the #1 candidate in the eyes of oligo, but it's always like this hyper focusing on if it's not the right answer for them, they're gonna be one of like the most hurtful things for the company. So it's like not being kind of the selfish person where it's like, I'm just trying to collect the most. I hate when people like output in Slack channels, they're like, I need the most cracked engineers to join my company. It's like, what does that even mean, you know? It's just finding the right people that actually want to build this multi-10-year vision that you're kind of dedicating your entire life to work on. It's like I'd only really hire people I would want to co-found the company with. And I think having that passion is so freaking cool.
Yeah, well, it's not just who you'd want to co-found with, it's people who want to co-found with you. And if you know what you're looking for, we literally put out a call of like, we need engineers with this specific skill set because none of us have it and we know it's critical. And we put that out in the channels of, we're lucky, we have access to MIT networks. We have access to networks of people that we used to work with at NASA and SpaceX. And I was able to do that and then just find a person who was like, I want to do that. I think it's really cool. I'm excited about what's going on in this space. I want to help. And the people who want to be there, that's a huge part of it.
Yeah, absolutely. I think that was, that was really interesting, and I appreciate the insight into what it takes to actually build a pretty good team, whether you're just starting up with your startup or whether you're pretty far into a startup. Yeah. Okay, so how did your time at MIT prepare you for your I guess beginning of a startup or just like working at a company? What qualities did you pick up from MIT or just going through the entire experience of your bachelor's, master's, etc.? Yeah.
I think it's so funny because everyone outside of MIT sees me. It's like, oh, you're a Teal fellow, you dropped out. But it's like, I cannot credit MIT, AeroAstro, Pam, who's outside at that table, George, Jeff, like Luca Carlone, every single person were the ones that like actually got me to get some degree of like confidence to even think of doing this. And I think to be in a position where you have the privilege to even think of doing this is something that is extremely underrated. I think just that entire environment, getting thrown into like lab projects where we were able to build a robot in the basement, you know, doing stuff like Rocket Team, getting thrown in all these different classes. But I think one of the biggest things was kind of just you're thrown into this massive sand pit that you can literally build absolutely anything in. And I think the MIT community has been super awesome, even after I like quote unquote dropped out, even though I'm like first generation. My grandma's gonna kill me if I don't put like a piece of paper on this wall. She's like, oh, Mio, ¿qué estás haciendo? It's like, it was so funny. And it's so nice to know that a community like this understands kind of that this type of stuff is worth pursuing, you know?
Yeah, I think I can definitely second that thought. Like, if you're sitting in this room, or I guess watching this presentation on the internet, you know, that probably means that you have, you know, you might have some degree of, you know, ability to actuate and, you know, make a space company. And I think that ability is something that MIT gave me. You know, MIT's got a great investor network, right? It teaches you the technical skills. I think that if you're in the position to take that step, you know, why not at least give it a go, right? Because you always have MIT to fall back on, like you're talking about I guess there's a shameless plug for AeroAstro network, yeah. But I think it's definitely a great position to be in, to be part of the MIT community and be able to jumpstart something.
I'd agree. I actually finished my degrees, but that is zero shade. I'm sorry.
I was like 5 classes away.
That's okay.
I was
it's
mini
okay.
classes
I'm not willing to take Peter Thiel's money because he doesn't think I should vote. But but you know, that is a very personal decision. That is again zero shade towards you. I think that the MIT. You guys are absolutely right. The MIT network. It enables a lot of imagination. I've met a lot of people sort of who are not connected to MIT, who don't work in aerospace very often, and they'll say things like, oh, wow, you know, I can't imagine doing that. And I'm just like, you know, you are not somehow less talented than me. But I was in an environment where if I said, hey, I want to work in space, that was a very real possibility. That wasn't a thing that people said, oh no, you should just go get a real job. So the enabling of the imagination here is really key.
I think another thing I can add to that is that at least when I was at MIT, I worked for a bit in the AeroAstro department. We worked crazy hard. I think ironically I probably worked harder. Well, that's probably about the same as making a startup. You know, like I feel like maybe MIT or AeroAstro, you know, engineers are some of the only human beings on the planet where going from you know the normal job to founding a startup is maybe not so huge of a jump. Like I remember, you know, this just crazy hours, and so I think that after the initial shock, you know, once you get used to it, it's doable, and then it's less painful when you have to do it for your livelihood.
I definitely agree with both that, and especially what Scarlet said about just like the enabling of the imagination. Like, I think being an engineer prior to coming to MIT, like I didn't even think I could work in space, honestly. It seemed so unattainable. And luckily now we're in an industry where there's startups popping up every day, and you know, Falcon 9 launches 3 times in 48 hours. Like all these things are happening that are so public facing and in a much larger presence than they used to be, that I hope it's feeling more attainable for more and more people. But definitely at MIT, being able to get all those connections and resources and attend events like this, I think is what really accelerated my ability to succeed in the space industry.
Yeah, no, the head start is awesome.
Yeah. Coolest friends on the planet undergrad. I think a couple of them are back there.
Oh, absolutely. I definitely believe it's the people at MIT that makes MIT as amazing as it is. Yeah. All right, pivoting a little bit back to, I guess, your startups, your companies. Say, fast forward 10 years. What does success look like for your company? And how do you hope to have changed the space industry?
Well, I know at True Anomaly in 10 years, like who knows what the space industry is going to look like. I'm so excited to see what new technologies or markets or players come into the game. But for True Anomaly, like I've said previously, our goal is to create a safe, secure, and sustainable future in space for for everyone, and I hope in 10 years that still exists, right? Like, it's becoming more contested as far as literally like the ability to get there, where you can operate, how you can operate, and we're hoping that that continues to be accessible and equitable to all, and then we hope to be part of that and be able to maintain that and have a proliferated, maneuverable spacecraft all across all orbits in order to help continue that goal and mission of making space safe for everyone.
Yeah. I think for Koller, one of the main things we're trying to do is turning spacecraft engineering into just a simple environmental engineering problem, where any single entity, any object we have here on Earth, becomes survivable into orbit via a programmed problem that automates the preparation that that entity needs to exist in the radiation environment in LEO, MEO, GEO, Moon, whatever it is.
Yeah, I think in 10 years' time, geez, that's a long time. I think I would want to see Basalt be kind of the enabling factor, and the fact that in space, it should be, the main challenge of space should be what interesting thing you want to do in orbit, and not how hard it is to turn on your spacecraft and commission it, right? Or use it in nominal operations. And I think that, you know, the software and hardware that we're building should help enable that.
Yeah, our mission is somewhat related. Mithril is just going to be a small part of a lot of this, because what we're really looking to do is make these types of reflectors software definable, make it so that we have flexible, agile tech in higher orbits. Because at the moment, you kind of have two options. You got software-defined, flexible, reconfigurable stuff for low Earth orbit, and you got expensive, exquisite stuff for everything else. We don't think it should be that way. We want to be able to take advantage of higher orbits. But for Mithril specifically, that means we start integrating into a new family of spacecraft that are going into higher orbits, that are making them flexible and agile. And that's a component play for us. And I think at the 10-year mark, probably, I personally might have moved on. I'm partly using Mithril as a little bit of a test case to figure out, is there a consistent play for technology transfer out of research institutions, for bringing out stuff that has been researched that industry can't take a risk on because it's too early, and figure out where it fits into, I hate saying it, the real world, but the real world. And how do we build a model for that so that we can get more tech out of research institutions, so it doesn't rely on people like me to just kind of come along and be like, hey, that thing that you researched for years is cool. Let's make it happen. It shouldn't be relying on an individual. We should have some better frameworks for that.
I think if I can add on one thing that you said, I think one thing I forgot to say is, I think it's going to be really interesting watching what people send to GEO and MEO in the next 10 years. They're going to send smaller things, they're going to send more things, they're going to do interesting stuff up there, and I can't wait to see that.
Hallelujah, we are finally seeing.
Please make GEO buses.
Next year.
We're seeing the end of the proliferated LEO mafia, hallelujah. Or at least like a slight quieting.
All right, yeah, absolutely. It's going to take a lot of companies that work on a lot of different technologies to get us into space. We've come to the end of our panel. I'd like to thank our panel for being here with us and sharing all of the advice and insights that you have. And thank you all for listening.